Welcome back to the Deep Dive. We're the show that, well, dives deep into complex topics, so you don't have to wade through everything yourself. We wrestle with the sources, pull out the key insights. Today, we're tackling something that causes, I think, a lot of head scratching and maybe some quiet teeth grinding in businesses everywhere. It's that communication gap, you know the one, between the software teams, the engineers, the tech leads, the architects, and the folks on the business side, the CEOs, CFOs, maybe marketing leads.
Mm-hmm. The non-technical leaders?
Exactly. And bridging that gap is tricky.
It really is. There's often a fundamental difference in how each side sees the world, especially when it comes to software itself.
Right. So for this deep dive, we've gathered quite a bit of material, articles, discussions, all centered around this idea that maybe software is never done. And specifically, how do you talk about things like continuous delivery or technical debt or refactoring,
Concepts that are bread and butter for tech teams?
but can sound like, well, jargon or maybe even excuses to stakeholders who aren't living it day to day?
Yeah, absolutely.
So our mission today is pretty straightforward. We want to pull out the best strategies, the most useful nuggets from these sources. We want to help you, whether you're the engineer trying to explain why you need to refactor something, or the CEO trying to understand why the finished product still needs budget to really get why this is so hard.
And more importantly, how to talk about it effectively, using language that actually connects with business goals, with the bottom line.
Because what really jumps out from all this reading is this core conflict in perspective.
Mm.
Development teams, they see software as this living, breathing, constantly evolving thing.
It's a continuous process, yeah.
But many business leaders, they often still view it through an older lens, like a project,
Mm.
something with a start date, a build phase, and a definite end, a finish line.
And that mismatch, that's where so much friction comes from. It's fundamental.
Okay, let's unpack this.
Yeah, that finish line idea. It's probably the biggest hurdle, and it's where a lot of the source material starts. This whole concept of a project start, middle, and comes from older ways of doing things, right?
Like building things, physical things.
Exactly. Construction, manufacturing, you design the building, you pour the concrete, you frame it up, put the roof on, eventually get the keys. It's done,
Yeah.
finished, tangible.
You can point to it and say, there it is.
Precisely. But the sources we looked at really hammer this point home. That legacy view, as they sometimes call it, just doesn't map onto modern software development, especially not with agile approaches and continuous delivery.
Because software isn't static, it changes.
Constantly. It's inherently dynamic, which is why that analogy kept popping up in the readings.
The one about software being like a living organism.
Yes, exactly. Software is more akin to managing a living organism than completing a project. Think about what that implies.
Okay, so a living thing needs constant attention.
Right. It needs feeding like new features or data. It needs protection security updates, bug fixes. It needs to adapt to its environment, new OS versions, competitor actions, changing user needs. It grows. It evolves.
You don't just plant a garden and walk away expecting it to flourish forever.
Perfect analogy. You have to weed it, water it, prune it. Software needs that ongoing care to stay healthy, secure, and valuable. You can't just build it, declare victory, and expect it to keep delivering value indefinitely without more work.
So why does this finish line myth persist so strongly if it's so clearly not how software works? Is it just habit from those physical industries?
I think it's partly habit, partly the influence of older software methods like waterfall,
Yeah.
where they tried to make it linear, even if it rarely worked out neatly.
Right, the big design up front, then build, then test, then massive maintenance phase.
Yeah, exactly. And then there's the language of traditional project management itself. Scope, deadline, budget. That language fits the finish line idea really well.
But it clashes with the reality of software that needs to keep evolving.
Totally. It creates these expectations that are just unrealistic for a living, breathing software product that needs to stay competitive.
And I bet so many people listening have been in that exact situation. You launch the big new feature, everyone celebrates.
High fives all around.
And then a month later, a senior leader asks, wait, why are we still spending money on Project X? Didn't we launch that?
That's right. Yes. It perfectly captures that friction point. It stems directly from that finish line thinking.
And the consequences are real, aren't they?
Oh, absolutely. The sources highlight this repeatedly. This myth leads straight to confusion about why there are ongoing costs. Why do we need continuous investment after the initial launch?
People expect a one-time purchase, like buying a building, maybe with some minor upkeep.
Exactly. But they've actually got this dynamic system that needs constant nurturing to stay secure, performant,
Yeah.
relevant. It misaligns expectations right from the start and basically guarantees tension down the road because that finish line they imagine just keeps receding.
Not because of bad planning necessarily.
Right, but because that's just the nature of software in the real world.
Okay, so that sets up the problem nicely, which brings us to the solution. The tech side often champions, but maybe struggles to explain. Continuous delivery.
Right. If software is this living thing, continuous delivery is like the advanced life support and development system you build around it.
Keeping it healthy and growing.
Yes. And the sources are really clear here. When you talk about continuous delivery to non-technical leaders, forget the technical plumbing. Focus entirely on what it enables for the business. Use their language.
What are the key business benefits then, according to the materials?
They usually boil down to a few core things. First, faster iteration. This is huge. It means the team can make changes, fixes, improvements, new features, and get them out to users fast. Like really fast. Maybe multiple times a day even.
Not waiting months for a big release.
Exactly. Which ties directly into the second benefit. Better customer feedback loops. If you release small changes quickly, you learn quickly. You see how users react almost in real time.
So you can adjust course based on actual data, not just assumptions.
Precisely.
Yeah.
It drastically reduces the risk of building the wrong thing because you're constantly validating with the market.
Makes sense. And the third one?
Competitive responsiveness. The market changes constantly, right? New competitor moves, new regulations, new opportunities. Continuous delivery gives the business the agility to react fast.
So if a rival launches something, you're not stuck waiting 6 months to respond.
Right. You might be able to get a counter move out in days or weeks. That's a massive competitive edge.
So the sources are positioning continuous delivery not as some optional tech trend.
No, not at all. They frame it as a cornerstone of modern software success, almost a requirement for staying competitive in digital markets.
And the translation point for leaders is
It's connecting those capabilities back to what they care about. Why does the CEO care about deployment frequency? They don't, directly. But they do care about getting value to market sooner. That's faster iteration. That means revenue or market share or hitting strategic goals quicker.
okay, and the feedback loops.
That translates to building what customers actually want, which means less wasted effort, higher customer satisfaction, better retention, huge cost savings, and revenue protection there.
And competitive responsiveness.
That's simple. Staying ahead of the competition, or at least keeping pace. It's about survival and growth in a dynamic market.
So the conversation isn't we need to implement continuous delivery pipelines because they're cool.
No, it's we need to adopt continuous delivery because it's the operational model that lets us deliver value faster, learn from our customers quicker, and outmaneuver our competitors. It's about business speed, risk reduction, and agility.
Got it. So continuous delivery provides the framework for ongoing development. But even within that, there are specific technical things that cause confusion. Let's talk about technical debt. That one feels like a big barrier.
Oh, it's a huge one. And you hit on why. It's invisible on a balance sheet. You can't easily point to it. It's abstract. So engineers talk about it, but executives are thinking, debt? What debt? Show me the loan document.
Right. So how do the sources suggest bridging that?
Overwhelmingly, the advice is use analogies they understand. And the best one, almost universally recommended, is the financial debt analogy. Technical debt is like taking out a loan.
How so? What's the low?
The loan is taken out when you make a pragmatic shortcut now to get something done faster. Maybe you skip writing automated tests for a feature to hit a deadline. Maybe you copy-paste code instead of building a reusable component because you're under pressure. Maybe you build on older infrastructure because upgrading would take too long right now.
Okay, so you get the short-term win speed, but you've taken on debt. What are the interest payments?
This is the crucial part of the translation. The interest payments are the ongoing negative consequences. The sources talk about instability and rising future costs. Let's make that concrete.
Yeah, examples help.
Okay, one big interest payment is more bugs. That rushed feature without tests. It breaks later. Fixing bugs in production is way more expensive and disruptive than preventing them. That emergency fix. That's an interest payment in developer time that could have been spent on new value. Plus, potential damage to reputation or lost customers.
Makes sense. What else?
Slower development speed. This is huge. As debt piles up, the code gets messy, tangled, hard to understand. Everything slows down. Adding a simple new feature becomes a major project because you have to carefully navigate the mess, or untangle it first. Yeah. That slowdown is an interest payment. It directly hits the business's ability to innovate and respond.
So the interest makes future work slower and more
Uh,
expensive.
Exactly. Another payment is system instability. Building on shaky foundations, using outdated libraries, that increases the risk of crashes, outages, downtime cost real money, damages trust. That's a big, painful interest payment.
And I imagine it impacts the team, too.
Definitely. The sources touch on things like lower morale, burnout. Talented engineers don't want to spend all their time fighting fires in a crumbling system. It makes it hard to retain and attract good people, which is another long-term business cost. That's an interest payment on your human capital.
So framing it financially, debt interest, that resonates because leaders get that.
Absolutely. They understand compound interest. They understand that neglecting maintenance on a factory floor eventually leads to breakdowns and costly repairs. You have to draw that parallel explicitly.
So don't just say, we have tech debt.
No. Say, we took a shortcut in Module A last quarter to meet the deadline, the loan. Now we're spending an extra 10 hours a week fixing bugs related to that shortcut, the interest payment, which is delaying feature B, the business impact. Make it concrete. Make it about business impact. It stops being a tech problem and starts being a drag on business performance.
Okay, let's switch gears slightly. Feature creep. That term sounds inherently negative, right? Like scope running wild.
It does have that negative connotation historically, like a failure of planning. But the readings offer a more nuanced take, which I think is really insightful, which is that sometimes what looks like creep is actually learning. It's adapting the product based on new information you gained after you started building.
So not always bad planning, but maybe responsive development.
Exactly. The sources talk about adaptive development as a potential strength, especially when it's managed properly. It's about realizing your initial assumptions might have been slightly off, or the market shifted, or user feedback revealed a better path.
Can you give an example?
Sure. Imagine you launch version 1 of a feature. Users start using it, and through analytics or direct feedback, you realize they're trying to use it in a slightly different way, or they need one adjacent piece of functionality to really make it useful.
Okay.
Sticking rigidly to the original spec might mean you deliver something nobody fully loves. Adapting, adding that ZOL-related piece based on validated user need that's not necessarily creep in the negative sense. It's making the product better based on real-world learning.
So the nuances between uncontrolled random additions versus deliberate managed evolution based on feedback or data.
Precisely. Unmanaged scope changes that derail timelines and budgets without clear strategic reason. That's bad. But adapting the plan because you learned something crucial that will demonstrably improve user satisfaction or market fit, that could be a smart business move.
How do you sell that reframing? How do you explain that this evolution isn't just making up for mistakes?
You connect it directly to the business outcome. Based on the user engagement data from the first cohort, the learning, we see that adding this small tweak, the evolution is projected to increase conversion rates by 15%, the business outcome. It's a strategic adjustment to maximize the feature's value.
So it's about framing it as data-driven optimization, not just scope change.
Yes, it shifts the conversation from why is this taking longer to how is this change making the product more successful. It turns potential creep into intelligent adaptation.
Which leads nicely to refactoring, another tough sell sometimes. Why pay engineers to rewrite code that already works?
Yeah, the classic don't fix what ain't broke mentality applied to invisible code structure. From an outside perspective, if the feature does what it's supposed to do, why mess with it? It looks like pure cost with no new functionality.
It feels like paying developers to tidy their root.
Kind of, and the advice from the sources is unanimous. You have to flip that perception. You need to demonstrate the hidden ROI. Focus entirely on the business benefits enabled by that tidying.
What are those benefits again?
The big ones mentioned are improved time to market for future features, reduced bugs, and lower long-term development costs. These are things executives care about.
Okay, break that down. How does refactoring improve time to market?
Because clean, well-structured code, the result of good refactoring is just easier and faster to change safely. Remember that messy code base slowing things down due to technical debt. Refactoring is paying down that debt.
Yeah.
So adding the next feature becomes quicker because the foundation is solid. Faster feature delivery means faster revenue or faster response to market needs.
And reduced bugs. How does internal restructuring stop bugs?
Simpler. Clearer code has fewer places for bugs to hide. It reduces complexity, makes dependencies obvious. When code is easier to understand, developers make fewer mistakes when changing it. Fewer bugs mean less time spent on fixes, lower support costs, happier users, better reputation.
Right. And the lower long-term costs.
That's the preventative maintenance argument. Spending a bit of time refactoring now avoids a situation where the code becomes so tangled and brittle that you eventually need a massive, expensive rewrite just to keep it functioning or to add critical new capabilities. It avoids hitting that technical debt wall.
It's like your garage analogy from before. Organizing it takes time now, but saves time finding tools forever after, or changing the oil in your car.
Exactly. It's proactive work. The ROI is hidden because it enables future speed and prevents future problems. So you have to make it visible
How?
by explicitly linking it. Investing 2 days refactoring this core module to work will make future changes in this area about 30% faster the benefit, allowing us to deliver the upcoming Q3 features 2 weeks earlier the business outcome. Or, cleaning up the air handling here will reduce related production incidents by an estimated 50%, saving X hours in emergency support per month. Connect the dots to time, money, or risk.
It really does all seem to come back to translation, doesn't it? Making those connections explicit. The sources emphasize this idea of proactively aligning technical work with business goals.
Yes, that's the central theme. It's not enough for the tech team to know their work supports the business. They have to actively communicate that connection using the right language and framing.
What does that look like in practice? What are the communication techniques?
It's fundamentally about translation. Taking a specific engineering task, maybe setting up automated testing, improving monitoring, upgrading a database, and clearly articulating its contribution to a strategic business priority.
Like revenue growth, cost reduction, customer sat.
Exactly. Revenue, cost, satisfaction, risk mitigation, efficiency, you name it.
Let's try another example. Connecting, say, automated testing to business outcomes. How would you phrase that?
Okay. Instead of saying, we need to build out our test automation suite, you might say, by investing in automated testing the task, we catch bugs before they hit customers' technical benefit. This means fewer production issues, which directly improves our customer satisfaction scores and reduces the time our support team spends on reactive fixes, business outcomes. Customer satisfaction, cost control.
What about something like improving system architecture? That sounds very technical.
Right, so not we need to refactor the data layer, but maybe improving our system architecture now task builds a stronger foundation technical benefit. This allows us to scale more easily as we add more users and lets us build complex new features much faster later on business outcomes. Scalability, future speed to market, enabling growth.
Even infrastructure upgrades.
Sure. Automating our deployment process task reduces the risk of manual errors during releases technical benefit. This lets us release updates more often and more reliably capability, getting value to users faster and allowing us to react quickly if we need to fix something, urgent business outcomes. Speed, agility, risk reduction.
Why is making that connection so vital?
Because it changes the entire dynamic. It moves the conversation from, why are you spending time on this internal tech stuff,
Yeah.
to how is this technical investment helping us achieve our strategic goals? It builds trust. It shows alignment. It fosters that sense of shared purpose we talked about.
And a powerful way to build that trust and demonstrate the connection is through data, through metrics. Executives often respond well to numbers.
Absolutely. Data cuts through subjectivity. But, as the sources stress, it has to be the right data, presented in a way that resonates with business concerns.
So what are the key metrics highlighted in the readings?
They tend to focus on metrics that reflect the overall health and efficiency of the software delivery process, which directly impact business performance. These are often called the DORA metrics, based on the Accelerate research.
Okay, like what?
First, cycle time. We touched on this. Basically, how long does it take an idea to go from starting work to being live in production, delivering value to users?
And the business translation is?
Speed to market, agility, efficiency. A shorter cycle time means you get value out faster. You frame it like, our cycle time is down 15% this quarter, meaning we launch feature X 3 weeks sooner than projected. Second is deployment frequency. How often are you successfully pushing changes to production? Daily, weekly, monthly.
This reflects agility again?
Yes. High frequency means you can deliver value incrementally, test ideas quickly, respond fast. You'd say, we increased deployment frequency to 5 times a week, allowing us to get critical security patches out within hours and test market hypotheses much faster. The third key one is mean time to recovery, or MTTR. When something does go wrong in production, an outage, a major bug, how quickly can you fix it and restore service?
So this measures stability and resilience.
Exactly, and its business impact is huge. Lower MTTR means less downtime, less lost revenue, less customer frustration, better brand reputation. You frame it as, our investment in monitoring reduced our MTTR by 50%. When we had that incident last Tuesday, we were back online in 15 minutes instead of an hour, saving an estimated X dollars in lost transactions.
Why these specific metrics?
Because they are outcome-oriented. They reflect the performance of the entire system development, testing, deployment, operations. And they clearly link technical capability to business results like speed, stability, and responsiveness.
But just throwing numbers out isn't enough, right?
No, definitely not. The sources emphasize presenting it clearly and persuasively, show trends over time or things getting better, use visuals, benchmark if you can, and always translate the metrics change into its tangible business impact. Connect the dots for them.
Okay, even with great communication and data, there's still that pressure point we mentioned, the just ship it mentality, when speed seems to trump everything else.
Yeah, that's a tough recurring challenge. The advice in the material is essentially twofold. Understand the risks yourself, and then articulate those risks and the false economies involved in cutting corners.
False economies, meaning it looks cheaper now but costs more later.
Precisely. Shipping fast by skipping quality checks, rushing code, ignoring potential scaling issues. It feels like a win in the moment. But it's classic technical debt accumulation. You're borrowing speed from the future with interest.
What are the typical interest payments or risks here?
Increased bugs, hitting users, obviously, system instability leading to outages, poor user experience damaging the brand, security vulnerabilities, and, crucially, the slowdown later on as the team has to constantly firefight or work around the accumulated mess.
So how do you push back constructively? The sources said diplomatically push back with clear context and data.
Right. It's not about saying no. It's about saying, yes, we understand the urgency. However, if we ship without completing these specific quality checks, the corner cutting, we face a significant risk of XEG, data corruption, system crash during peak load, which could impact YEG, customer trust, Q3 revenue goals. The potential cost of failure outweighs the benefit of shipping 3 days sooner. Can we agree on accepting this level of risk, or should we take the extra days?
So you frame it as a business risk assessment, not a technical complaint.
Exactly. You make quality a non-negotiable asset tied directly to brand reputation and business velocity. Skipping quality isn't just risky technically, it's risky for the business. You provide those concrete examples. Remember the outage last year? That was caused by rushing a similar deployment. It cost us 0Z and took weeks to fully recover. Make the potential pain tangible.
It really feels like all these specific tactics, explaining concepts, using metrics, handling pressure, they all point towards a need for a broader cultural shift. The sources seem to end on that note.
They absolutely did. Bridging this gap isn't just about one conversation or one presentation. It's about building a sustained culture of continuous understanding.
What are the key ingredients for that culture, according to the readings?
3 main things came up: ongoing education, mutual respect, and shared language.
Okay, ongoing education. That sounds like it goes both ways.
Definitely. Tech teams need to learn the business strategy, finances, market pressures. Business leaders need digestible insights into the why behind modern software practices, why iteration matters, why tech debt is real, the value of things like refactoring. Think regular demos focused on business value, maybe internal workshops, just consistent dialogue.
And mutual respect.
That's fundamental.
Sure.
Recognizing that both tech and business bring essential expertise. Business sets the direction, tech builds the engine. You need both, working as partners, not adversaries, valuing each other's perspectives and challenges.
And the shared language is built through consistently using those translations we discussed.
Exactly. Using those analogies, financial frameworks, focusing on outcomes. Over time, you develop a common vocabulary, a shared understanding of key concepts, which makes collaboration smoother and reduces misunderstandings. It takes deliberate, ongoing effort from everyone.
There was that one line that really seemed to tie it all together, linking back to the start. Helping executives think in iterations and not endpoints is key to long-term collaboration.
That's the crux of the cultural shift, isn't it? Moving away from thinking in finite projects with fixed finish lines towards embracing a continuous flow of value, learning, and adaptation. When the whole organization gets that software is a journey, not a destination, the relationship fundamentally changes.
It becomes a partnership focused on maximizing that ongoing value stream.
Precisely.
Yeah.
And that aligns the culture with the actual nature of the digital products being built.
Okay, so let's try and summarize the core takeaway from this deep dive, echoing what we found in the sources. It seems like selling continuous delivery or any of these concepts isn't about oversimplifying or dumbing down the tech.
No, not at all. It's about effective communication. It's about storytelling, finding the right analogies. It's about translation, consistently linking technical activities to business outcomes. And it's about alignment, ensuring everyone understands how the engineering work contributes to the bigger picture.
Taking that complex internal world of software and making its value clear in the language the business understands: speed, cost, quality, risk.
Exactly. Telling that story clearly and compellingly.
And that final powerful thought from the material really sticks. Remember, software is never done, but that's not a problem. It's a competitive advantage when understood correctly.
That last phrase, when understood correctly, that's everything. That understanding is built through the communication, the translation, the shared language, the cultural shift. That's what turns the dynamic nature of software from a point of friction into a strategic weapon.
So, for you listening, the question becomes, how do you start applying this? What technical concepts cause the most confusion in your world? What business outcomes matter most to your stakeholders? How can you start framing the technical work differently, focusing on its value? What's one small step you could take this week to start building that bridge? And maybe a final thought to chew on, pushing this idea further. If embracing the never-done iterative nature of software is a competitive advantage, where else in your business might that traditional finish line mentality be holding you back? What other areas could benefit from thinking more in terms of continuous adaptation, ongoing improvement, and deeper cross-functional understanding? Food for thought. That wraps up this deep dive. We really hope unpacking this helps you bridge those communication gaps and foster a more collaborative and effective environment, whether you're on the tech side or the business side. Thanks for joining us.